So good day everyone. I'm Apple Valdasco from BSCS 3IS1, and for today I will introduce to you another algorithm to use aside from k-means clustering. So here are hierarchical clustering for us to improve our model more better. So, hierarchical clustering is a method of grouping data points such as our customer in our datasets mall customer based on their similarities. The idea is simple. We will start by treating each data points as its own separate group. Then we will repeatedly find the two most similar groups and combine them into a single group. This process continues until all the data points are in a one big group. The key feature of hierarchical clustering is that we don't need to decide the number of groups or clusters in advance. We can explore the result and choose the number of clusters later based on how the groups are formed. So here we start by importing important libraries like pandas. Pandas help us to make it easier to load, manipulate, and analyze our datasets. The matplotlib, the pyplot, and the cform libraries help us visualize our result later on. It helps us understand the relationship of our features. So the line 5 loads the datasets from CSV file into a pandas data frame called mol data. So the read CSV functions um, opens the dataset so we can work with it easily. So the mol data that held functions display the first few rows of the datasets. It helps us to inspect our datasets and to know what we will do next. If there are missing values, duplicates, or null values, and to know if our datasets contains numbers or text. We can provide solutions immediately. So here we will prepare the data for clustering by making sure the features are on the same scale. First, it selects two important columns from datasets, annual income and spending score, as these are the features we want to use for grouping customers. Next is we will use the standard scaler from the scaler.preprocessing library to scale these values. Scaling means adjusting the data so that the both features, income and the spending, have a similar range and influence on the analysis. This is important because clustering algorithms like hierarchical clustering often rely on distance calculations, and if one feature has much larger values than other, it can dominate the results and lead to biased clusters. So by scaling, the data becomes easier to compare and analyze fairly. So here we are creating a dendrogram, which is a visual representation of how customers are grouped together step by step in hierarchical clustering. First, it uses the linkage function from the SciPy library to calculate the distances between customers based on their scale data, the income, and the spending score. The word method is used which minimizes the variation within each clusters as they are merged. The dendrogram function then plots this information in a tree-like diagram where each branch shows how and when clusters are combined. The x-axis represents individual customers or clusters, and the y-axis shows the distance or the similarity between them. The dendrogram helps us decide the number of clusters by looking for a long vertical line that can be cut to separate the groups. It's a key step in understanding the structure of the data before finalizing the clustering. So for the hyperparameter tuning for the clustering, we first import the needed libraries, and this will identify the best clustering method and the ideal number of clusters for the datasets. It tests for leakage methods, the word, single, complete, and average, which determine how distances between clusters are calculated. For each method, It evaluates clusters grouping from 2 to 10 clusters using the silhouette score, a metric that measures how well separated and cohesive the clusters are. Higher scores mean better clustering. So after calculating the silhouette scores, it identifies that the word method is the most effective. As we can see here, best leakage method is word, and the optimal numbers of clusters is 5. As this combination gives the best scores, this process ensures that clustering is accurate and meaningful, helping to group customers effectively for better insights. So here we will fit the model with the best leakage and the number of clusters. Earlier, we used hyperparameter tuning to test different leakage method and clusters numbers to find the best combination. The word method and 5 clusters were chosen and the most effective based on the silhouette score, which measures how well customers fit in the assigned clusters. Now, using this information, we build the clustering model with the agglomerative clustering algorithm. Each customer is assigned to one of the 5 clusters, and the results are added to the datasets in a new column called cluster hierarchical. So we chose the annual income and spending score features to see the relationship between the two. So this scatter plot shows how customers' spending behavior changes based on their income. So there's high income, high spending group. These are premium customers who likely prepare luxury or exclusive services. There's is also low income, of course, low spending group. This customer might benefit from discounts or loyalty program to boost their engagements. So there's is also high income but low spending group. We also test another feature pair, which is the age versus spending score for experimentation only. So the age versus spending score plot highlights how spending varies with age. For example, younger customers may have diverse spending patterns while older customers spend more consistently. So for the third comparison, we use the age and annual income features to test their relationship. The age versus annual income plot shows the relationship between age and income, where middle-aged individuals often have higher incomes, while younger and older groups may cluster in lower income groups. For the fourth experimentation, we test the gender and annual income feature. The scatter plot of gender versus annual income shows how annual income is distributed between male and female customers. If men have higher income levels, businesses may focus on products with higher price points for male customers. If there is no significant difference, this suggests that income based strategies should target both genders equally. So, to give you a conclusion about my overall finding and result, the annual income versus spending score is the best pair for clustering because it shows both the financial capacity and spending habits of customers. Income reveals how much a customer can afford, while spending scores shows how much they actually spend. Combining these two helps identify groups like high income, high spending customer or low income, low spending customers. As we can see earlier, mas cluster sa annual income versus spending score. Unlike sa ibang features na natas natin, um, overlap yung iba. Tapos, halo-halo sila. So as I can say then, hierarchical clustering is an effective tool. Aside from k-means clustering, it is also an alternative for segmenting customers, providing clear insight into their behavior. By understanding these patterns, businesses can create targeted strategies, allocate resources efficiently, and make better decisions. That's all for my report. Thank you for listening.